everybody. Just getting started here. Wow. Good morning, everybody. This is a live emergency briefing as we have a moderate risk that was issued by the Storm Prediction Center from southeastern Nebraska to northern Kansas. That is for damaging straight line winds. However, up there, just a greater coverage of storms expected, but there's also a threat of strong to potentially violent tornadoes up there as well, really all the way from the I-80 corridor down to I-40, along I-35 down to the Red River. Does have the potential for a conditional threat for strong to potentially violent tornadoes. Any supercells that are able to develop along a dry line are going to have a potential of producing that dangerous severe weather. And of course, I'm going to be activating storm chase mode. I'm already in position near the Kansas-Oklahoma border. And today is going to be a discussion of, do we head all the way up into the moderate risk? A lot of storm chasers are going to be up there with that upgrade in the probabilities, or do we stick to the dry line with a slightly more conditional but more isolated development of supercells that is anticipated? There you can see the new moderate risk. I wouldn't be surprised, though, if that moderate risk is extended off to the south, because I do think that the threat of convective initiation is only increasing. One thing that would cause me to blast all the way up to southeastern Nebraska would be if this low-level jet were wrapping around a more potent 850 low, but I do think that the shape of the ejecting trough, basically a flatter trough ejection with the jet exit punching into central Kansas, playing that left exit region, I believe that where the left exit is coupled with the dry line, that causes this low-level jet to verify a little bit closer to the dry line, with 50 knots verifying right up against the dry line, southern Kansas into northern Oklahoma. That's where I believe the greatest threat for potentially strong to violent tornadoes exists. Up here, you see the 30-knot low-level jet. It doesn't quite wrap around the eastern periphery of the 850 low. It's just not as compact as it could be to target more of an arc up here across southeastern Nebraska. That's where the moderate risk is located. But let's take a quick look at some of the other models here as well. Let's take a look at the 3-kilometer NAM and focus on that shape of the low-level jet. And then I'm going to focus on the shape of the upper level system and show you where it is coupled, more closely coupled with the dry line, the left exit region. It's important to focus on these jet circulations when you're looking at setups like this and trying to pick out a more favorable trough. It does look like the convective allowing models are bringing the triple point a little bit closer to the I-70 corridor. And notice how the low-level jet just doesn't quite wrap around that 850 low as you'd really want in that area of surface southeasterly winds, southeastern Nebraska to north central Kansas. I do, however, love this parameter space for tornado potential from central Kansas down even into northern Oklahoma. This is the 850. These are the 850 winds at 0Z. Definitely do verify right up against the dry line. It does seem like we are getting a little bit of a southward trend amongst the NAM models. Let's take a look at the HRRR model and see where that low-level jet verifies at 0Z. This is at 7 p.m. this evening, probably when the tornado outbreak is going to peak. And interestingly here on the HRRR, it does wrap that low-level jet a lot more around a more compact 850 low into southeastern Nebraska. That would definitely boost the tornado potential across southeastern Nebraska. Right now I'm in Blackwell, Oklahoma. The internet is a little bit questionable here right now at this hotel, so that's why some of these images are loading a bit more slowly. But look at this low-level jet right up against the dry line, banked up against it, southern Kansas, central Kansas. You probably want to target the nose up there just a little bit into central Kansas. Most of the models do take a surface low right along that boundary. And we see the word triple point getting thrown around a lot. And basically all that is the intersection of a cold front that's marching to the south on the west side of the surface low, and the intersection of a dry line, 3 different frontal boundaries, and a warm front that extends off to the east. So those southeasterly winds, the warm front really probably noses up into southeastern Nebraska in terms of a temperature sense, and then you get a little destabilization to the north of the warm frontal zone, southeastern Nebraska, northeastern Kansas, ahead of that potent surface low that'll be moving pretty close to the Kansas-Nebraska border. The HRRR, however, does pinch off pinches off the surface low just a little bit further south, down closer to the I-70 corridor. That's where it looks like that surface low should settle in, and in fact brings the triple point all the way down to near Wichita by 0Z. Look at the front surging down to the south. So still we have a lot of these model discrepancies that exist right up to the event amongst the short-range convective allowing models. Look at the triple point in the 3-kilometer NAM with a cold front surging south to the west. You've got a dry line extending south as well, warm front, a diffuse warm front extending out to the east, probably closer to the I-70 corridor. Another warm front extending to the east of that effective triple point through the Flint Hills region. And boy, it looks like the 3-kilometer NAM is showing that triple point much further south. And I suspect that's because of this flat upper trough and the ejection of the jet exit a little bit further south. And let me show you what this looks like. The upper jet dynamics are important. I see some young meteorologists, especially at the University of Oklahoma, that are definitely prioritizing jet circulations, jet dynamics. It's really the only way to pick out the best target area. So here you can see the mid-level jet. You basically have this lead perturbation as well that overspreads the target area. Once this blasts through, that's going to create lift along the dry line. But definitely up here across southern Kansas into central Kansas appears to be favorably located. You can see this 50-knot mid-level jet streak right across the Kansas-Oklahoma border, northern Oklahoma. To the south of that feature, the convective initiation, the probability of initiation is a lot more conditional, and that's central Oklahoma down to the Red River. But if a storm does fire along this wave, southwest Oklahoma, it's going to head toward the Oklahoma City metro with extreme tornado potential. There you can see the exit. It does appear that the left exit region favors far northern Oklahoma into southern, even central Kansas amongst this zone, at least at 500. Let's zoom out. Let's use the regular NAM to really assess this jet structure. But that's clearly why the NAM model is compressing the triple point a little bit further south. This jet, it's a flatter trough ejection. This jet's coming in west to east, really the left exit region, targeting Wichita down to the Oklahoma border. Even northern Oklahoma is included in that jet exit. And the jet is coming a little bit further south according to the NAM model. We can look at it especially up a little bit higher in the troposphere, near the tropopause, to look exactly where that jet exit is nosing, and look at it, nosing right in along the Kansas-Oklahoma border. That's the focus of today's briefing, using the upper level jet dynamics to target the most favorable location along a large warm sector to target severe weather. And you can see that the jet is a little bit weaker, a lot weaker further north across the moderate risk area, southeastern Nebraska. You got to wonder if some of those updrafts aren't going to be as favorably ventilated further north, especially as they are a little bit further south, more classic supercells forming off the dry line. But that's the left exit region. The right entrance region of a jet, upper level jet, is also associated with lift. But the left exit nosing into the dry line, that's where I'm going to be targeting, probably near Wichita, southern Kansas. But let's take a look and see where the other models nose that jet. It does look like the HRRR tries to bend a little bit of a nose further north across northern Kansas. That's probably why the HRRR has a triple point just a little bit further south. The NAM, though, seems to continue this jet streak across the Oklahoma-Kansas border a little bit faster as well, more progressive amongst the NAMs. This is a lead wave here, lead disturbance that comes across. You may have seen Mike Morgan commenting on lead wave, even calling Gizmo lead wave there. It's this wave, this jet streak, that moves over the dry line that will have the potential of setting off convective initiation by about 5 or 6 o'clock along the dry line. Central Oklahoma down to the Red River is a little bit less favorable of a position relative to the left exit region. Let's also look at this very tight dry line. When we talk about the triple point, we talk about the three boundaries. There is a very tight dry line here, nosing into central Kansas along the I-35 corridor. A bit of some wraparound moisture right along the nose, far northern Kansas up in the moderate risk area. But decent dew points, mid to upper 60s all along the dry line. Down central Kansas, central Oklahoma, anywhere along the I-35 corridor from I-70 down through I-40. We'll have the potential of tornadoes. And then look at the dew points back behind the dry line, dropping into the teens. Extreme or critical fire danger out here behind the dry line. That's equivalent to a high risk for fire, but you're going to have those really strong southwesterly winds behind the dry line, coupled with very low relative humidity that's going to be exacerbating that threat of wildfires, especially very dry winds out there, stronger winds mixing down to the surface. Not quite the 50, 60 mile an hour winds that we saw with the last system. A little bit weaker in the way of 850 winds behind the dry line. That'll be getting mixed down, but still gusting 30 to 40 miles an hour. More than sufficient to generate an extreme wildfire threat behind the dry line. So now let's take a look at the 3 kilometer NAM parameter space. We can look at the energy helicity index. We can look at the significant tornado parameter. We looked at the upper level jet dynamics. We also need to look at the surface map additionally to verify just how strong that moisture is coming in. Look at this low level jet right up against the dry line across northern Oklahoma up into southern Kansas. That's where we're targeting. That's where we do think that there's going to be the development of supercell storms along the dry line, coupled with that left exit region of the jet, probably developing near the Kansas-Oklahoma border. Look at the 3 kilometer NAM. Fires a storm across far northern Oklahoma right in this target area. 3 kilometer NAM definitely likes the northern Oklahoma area for conditional development of supercell storms. Also has kind of that windbag developing further north, northern Kansas into southern Nebraska as the triple point gets compressed south with the front bulging down to the south, pinching off the triple point down into south central Kansas. I suspect you're going to get a supercell developing right here as well, south central Kansas, and one across north central Oklahoma, and a little bit more conditional, that threat further south for a tornado potential. Of course, we'll go right to the significant tornado parameter. Look where it's maximized. South central Kansas, north central Oklahoma. You've got a hole right in that parameter across north central Oklahoma as well that's likely going to fire. Triple point sagging south to near the Wichita area. An extreme parameter space for strong to potentially violent tornadoes south central Kansas and north central Oklahoma. We can look at a forecast sounding, forecast photograph here. Probably going to be a PDS tornado sounding. Just a there it is. It is a PDS tornado sounding. Classic dry line sounding for strong to violent. Loaded gun sounding here. Capping inversion. Big elevated mixed layer. Thick cape. You're talking cape pushing 4,000. Directional shear and speed shear. And your low level jet really probably verifies greater than 50 knots ahead of that storm. So you're going to elongate that low level shear vector even more substantially. East northeasterly storm motions at about 30 knots. Definitely more than manageable as well. So a pretty big time dry line event here. And I am starting to hone in on this area in southern Kansas and northern Oklahoma, just based on the jet structure. It's a lot more west to east down there as well. Even the HRRR is starting to pick up on this high-end parameter space, south central Kansas and north central Oklahoma. I'm currently located in Blackwell near the Kansas-Oklahoma border right now. I don't see any motivation to blast off to the north. I got some text messages coming in from Scantman and Connor. Just got a message from Connor. He's not sure if he's going to make it up here or not. He's got some vehicle troubles. His wheel fell off. Does sound like the Scantman, though, is going to be coming out here to target this high-end parameter space, northern Oklahoma into south central Kansas. Let's see if the convective allowing models fire storms out here. This is the HRRR model, which is notorious for leaving this dry line warm sector completely clean. But of course, there's going to be convective initiation along that dry line, definitely exacerbated by the left exit region. So we are going to side with the NAM model. It definitely seems to have a better handle on that more west to east jet streak right along the Kansas-Oklahoma border. Seems to have a better handle on the dew points as well along the immediate dry line, central Kansas into central Oklahoma. But look at this windbag, southeastern Nebraska. Pinched off a bit. That's going to form along the cold front off to the north. Well, there you can see the surface low ejects northeast, but the effective triple point gets pushed down a little bit closer to Wichita as it gets pinched off. This cold front continues to head southeast. Here's the dry line, so the effective triple point gets pinched to the south of southeastern Nebraska into central Kansas, according to the HRRR. It definitely is trending toward the 3-kilometer NAM as well. But the regular NAM, of course, has a very good handle on that trough ejection. Let's take a look at the photographs again here. And we'll go back over to the 3-kilometer NAM photographs as well. Make sure I'm still live even on here. Good, looks like we're still going. Welcome, everybody. So here are the photographs overlaid with surface-based instability. And look at that one down into north central Oklahoma into south central Kansas. Anywhere to the south of that effective triple point by 0Z looks incredibly dangerous for strong to potentially violent tornadoes. And that includes all the way ahead of these storms across eastern Kansas as well, as those storms move into that environment. I think this is gonna be an outbreak, and a pretty impactful outbreak here across Tornado Alley. Definitely the highest end setup we've seen in Tornado Alley in quite some time, probably since 2019 with this one. And I'm trying to plot out the photographs here. Definitely photographs that are supportive of a tornado threat, even up to the east of the 850 low, southeastern Nebraska, north central Kansas. You definitely aren't gonna be shamed for playing that northern target. A lot of times these outbreaks are bimodal. Even if they're relatively compact, you'll get a cluster of severe weather off to the north. You'll get another cluster of severe weather off to the south. It looks to me like the southern mode is probably going to be north central Oklahoma, maybe as far south as Oklahoma City as well. But it does look like a very impactful severe weather day. This area, anywhere south central Kansas, north central Oklahoma appears logical to target. You also could target up to the east of the 850 low. The HRRR tries to wrap that instability and shear around a more compact 850 low further north. You're just going to be battling with the cold front as well, likely undercutting some of the updrafts. A little bit drier up there as well. Definitely looks like the 3-kilometer NAM convects this area, pinches off the triple point into south central Kansas. And look at these photographs. Just nasty photographs out there. This one is definitely exacerbated by weaker winds there right around that immediate supercell storm. Look at that major 0 to 1 kilometer shear, conducive for a strong to violent tornado, very long low-level shear vectors as well. Looking at the 0 to 1 kilometer storm relative felicity, you can see how that area is enhanced by the storm in that region in south central Kansas. Cold front coming south. 3 kilometer NAM storm relative felicity. This is at 23Z, and it increases even further between 6 and 7 p.m., as is often the case with these dry line setups. Look at the increase in the low-level wind shear. Does seem like the low-level wind shear is greater on the Kansas side, a little bit closer to the pinched off triple point. It gets pinched down into south central Kansas. Definitely in a dramatic fashion. You get a dramatic increase there in the 0 to 1 kilometer SRH, storm relative felicity. Here it shows your overlap of the greatest instability with the low-level wind shear, 0 to 1 kilometer shear. Definitely shows this favorable dry line, favorable parameter space to the east of the dry line, and you can see the undulations in the dry line as well. You definitely want to target where the dry line is a bit more north-south for initiation of storms. Seems like that is going to be most likely across north-central Oklahoma into south-central Kansas, and then that dry line bends back to the southwest across western Oklahoma. High-end parameter space here for tornadic supercells. PDS tornado soundings all over the place. Definitely the convective allowing models are showing this cap to be breached by about 5 or 6 p.m. And then parcels will tap into this very thick cape aloft. Abundant instability, elevated mixed layer punching in at the mid-levels as well. Very large looping hodograph, 1 kilometer wind, accelerating up to about 50 knots out of the south-southwest. Well-ventilated supercells, especially with your directional shear between 1 kilometer in the mid and upper levels here. Evacuating the rain and the hail from the rotating updraft of these storms. So I'm going to be targeting this zone, north central Oklahoma, south central Kansas, but realizing that a supercell could also develop across southwestern Oklahoma, move up I-44, and then head toward the Oklahoma City area. And then the threat on Saturday ejects across central Illinois, central Indiana as well, and then a new severe weather threat on Sunday across the South Plains of Texas is going to materialize. Three kilometer NAM lights up a supercell north central Oklahoma along the 412 corridor. Also appears to ignite one up near the triple point, south central Kansas. Also picks up on the greater threat of wind across southeastern Nebraska and north central Kansas as well. Let's take a look at satellite and the surface map. We're kind of doing this backwards a little bit. We'll go over to the real obs. And we should be bringing out our colored pencil set, breaking this down. Storms are ongoing up here in MCS across northeastern Kansas, northwestern Missouri. You got to wonder if that's going to help to solidify the warm front a bit and help with that further south, help facilitate the further south pinching off of the triple point. Deep moisture, low to mid 60s dew point streaming northward, more than sufficient. And it's possible you could even get some mid 60s dew points. You can see just to the south of DFW, some of those mid to upper 60s dew points. Definitely would favor a little bit further south of a trend. These are the real obs that we're looking at. Remember that temperature is on the top, dew point is on the bottom. The red number is temperature, 74 over 62 out there. Near Clinton, 12-degree temperature dew point spreads. Stratus deck. Really though, hoagie buns are just streaming northward that are basically parallel to the southerly low-level jet. I do want to look at a real sounding here as well and show you what that low-level jet looks like at OUN this morning. I think in my AsLive I said that it was gusting like 50 to 60 knots just above the ground, and it's not really that intense. It's like 45 knots on the morning sounding from OUN. You can see that stout capping inversion. It's the loaded gun sounding as we talk about it. The temperature will continue to increase underneath that cap until it hits the convective temperature, and then parcels are able to access the thick cape aloft, facilitated by these very steep lapse rates The rate at which temperature decreases with height is maximized right in the vicinity of this elevated mix layer. Look at that elevated mix layer in the mid-levels of the atmosphere. Photograph, obviously, indicative of a very strong low-level jet just above the ground. But that's a very steep lapse rate in the mid-levels of the atmosphere. Real soundings. Very thick elevated mix layer as well in the mid-levels of the atmosphere. Ooh, you can see those cloud sheets, hoagie buns. Bit of an outflow boundary here with some gravity waves along it as well into central Kansas. There's your satellite image. Cloud sheets are oriented south to north, parallel to that low-level jet. Come on. But really, as I just posted on Twitter, you basically have these hoagie bun clouds that are parallel to the low-level jet. That's really about 45 to 50 knots just above the ground instead of 50 to 60 knots. Looking at satellite, of course, those clouds are going to burn off, no problem. You're going to have big-time instability. No issue at all with instability, that's for sure. April 26, 1991, all over again. I am seeing that report from Mike Morgan. He's just coming out right now. That was the Red Rock tornado, also Andover up there as well. I definitely agree with that analysis. I do think Mike Morgan is the best out there at radar breakdown during severe weather. Just a master communicator, great forecaster, experienced forecaster as well, especially here in the Tornado Alley. I'd be honored to work with Mike again at Channel 4. Probably work there for free just to have the opportunity. Looking at the forecast wrap. Instability already building beneath that cap. Loaded gun soundings coming to fruition out here. And look at that, already by 20Z. That northern target could go early, especially according to the wrap. Looks like the wrap really likes that north central Kansas into southeastern Nebraska target. Look at those east-southeasterly winds across north central Kansas. It seems to have a less effective pinching off of the triple point up there as well. But look at that 0 to 1 kilometer shear that builds in the southern mode. South central Kansas into north central Oklahoma. And that's going to build back to the dry line after 20Z. But at 20Z, it has the greatest 0 to 1 kilometer, at least effective 0 to low level wind shear, bending right around that surface low into southeastern Nebraska, north central Kansas. So that triple point up there does look interesting as well. It's only the 3 kilometer NAM that pinches off the triple point into south central Kansas. Jet dynamics certainly favor that target as well. But there's likely going to be strong to violent tornadoes into southeastern Nebraska ahead of that main surface low, depending on how fast the cold front back behind it surges. The wrap definitely likes it up there. Southeastern Nebraska, north central Kansas. Really hard to go wrong with this setup. The leading analogs, definitely April 26, 1991. You know what happened that day. The F5 tornado near Andover. Long track tornado, the Red Rock tornado up here near the Kansas-Oklahoma border. Still some damage to the cottonwoods up here, as Mike Morgan has let me know. That "let me enlighten you" people joke that I said on Twitter is obviously from the movie Twister, everybody. Those that haven't seen it or aren't aware, that's okay. It's kind of a funny joke from Dr. Jonas Miller. All right, everybody. So the theme of this morning briefing is that we are using the upper level jet dynamics, the lift associated with the left exit region, to determine our target area. And we'll look at the NAM. I can just assess. We'll end this briefing just looking at the overall upper level trough shape. This is this morning. You got this nose, a ski jump configuration, punching into northern Oklahoma, southern Kansas, at least according to the NAM. The other global models to also show this. Look at this jet streak coming south a bit. It doesn't really wrap north into southeastern Nebraska, or I'd be targeting that area. More of a westerly shape to the upper level jet with that wave. Once that moves over the dry line, boom, those supercells are going to peel off that dry line, moving in an east-northeasterly direction. Let's look at the trough shape on the 6Z GFS. It is a little bit further north, so at least the 6Z GFS argues north central Kansas would be more co-located with that jet max. So I think the key to this forecast is seeing exactly where that jet max is going to go. The 12Z NAM still has it a little bit further south, that jet streak paralleling the Kansas-Oklahoma border. That would keep south central Kansas more in play. Wichita, you're going to be right in this action zone. Wichita down to Oklahoma City. Salina, Wichita, Oklahoma City, really. Even York, Nebraska, up further north. See what the European model does with the shape of the upper level jet, shape of the upper level trough that's ejecting. Wow, the European model, the 6Z European model is a bit further south with that jet as well. Kind of an average between the GFS and the NAM models. Let's see what the 6Z NAM was showing. 6Z NAM further south, in agreement with the 6Z European model. Definitely not bending up that lobe off to the north of the GFS. And the HRRR are showing. But there is the 6Z to the 12Z trough shape, even more solidified with that channel, that jet axis right on the Kansas side. So I think Wichita does look like the target. Wichita down here to Blackwell, definite target area, south central Kansas and north central Oklahoma. Basically winds perpendicular to the dry line arriving. And that threat does extend down to Oklahoma City, but Oklahoma City down to the Red River, a little bit less favorable jet dynamics. So a lot more conditional for the supercell development from Oklahoma City down to the Red River. So thank you, everybody, for tuning in to this morning weather report. I think I'm going to be teaming up with Mike Scantlin on this chase. Connor was also supposed to come up from Dallas early this morning. Looks like he's going to probably be targeting the southern mode as well. Looks like I got a bunch of dropped frames due to this live stream, some botched internet here. But thank you, everybody, for tuning in. Full-blown storm chase mode certainly is going to be activated. Sign up for those notifications for when I go live on Facebook and on YouTube, of course. Ring that notification bell. Do what you got to do. So thank you, everybody. We're also going to be deploying gravity wave sensors in the path of these tornadoes. I've definitely got to clear those off, clear the gravity wave sensors as well. Get ready for that. Also, stay tuned. We got a live streamed class of varsity tutors coming up on Monday. That's going to be a real live storm chase. Looks like that's going to be a target area, central Oklahoma. Sunday could also happen across the southern Texas panhandle. Full-blown storm chase mode is activated as we are transitioning into early May. Very active period, rivaling 2003, 2016, a very legendary year for tornado potential and severe weather. Appears likely as Tornado Alley, at least the southern portion of it, is waking up in a big way.